Hi everyone. In this video, I would just like to discuss with you an interesting step problem from the step database, and that is in fact a very it has some very beautiful problems. This is only a step one question, but I think it's interesting to see, especially if you're an IB student, how which approaches we can use to solve this. And I feel like this would come up in an IB. Something on the lines of this could come up on an IB exam too, or isn't at least on the approach that we can use here. And so it's very what they say. I've written the problem out here for you, the basic important parts of the problem. So they say two numbers x and y are such that they both belong to real, and they satisfy the equation 4x squared plus 16xy plus y squared plus 24x is equal to 0. And so they say show that x less than equal to 0 or x greater than equal to 2 or 5. These are the restrictions we're trying to prove. And also they're saying find the restrictions on y. So how would we start with this problem? So now that we've read the problem, we can head into it, right? So we're given this equation. I'll write here in blue. 4x squared plus 16x y plus y squared plus 24x is equal to 0. And we know x and y both satisfy this equation. So firstly, we'll of course try to find out the restrictions on x. And we must find x first. So I mean, if we look at this initially, we would try factorizing it. We could try adding some term attempting to factorize it. But in fact, there's a much simpler approach, and you may have already recognized it. But I think it's important to see this because it is a very it helps us understand the importance of strategy too. So if we think about this, I'm just going to write on the side here the goals we have. Goals. Find restrictions on x. So implies we must solve equation for x. Then use that to find restrictions on y. And it's a very basic approach. We're practically following what the question says. It tells us we're going to find restrictions on y, and then we're going to find restrictions on x. So I'll put this here on the side as a small box, just for us to refer to quickly. So coming to the problem, how can we approach this? What if we write this in terms of y? I mean, of course it's in terms of y, but just to express it, we can write it as y squared plus 16x times y plus 4x times x plus 6. Assuming x is some part of the coefficients. And here we are. We've got a quadratic in y. Well, again, you may think, how are we going to proceed? And here's the trick. We can just use the discriminant because we know that x and y, so I'll write here, as x and y belong to real, implies the discriminant, which is equal to b squared minus 4ac for a general quadratic function, is such that discriminant is greater than or equal to 0. And this is the trick in this problem. This is what we're going to use. So implies we know y is equal to minus b, so minus 16x, plus or minus the root of b squared, 16x squared. minus 4 times A times C. And this is our quadratic formula. But we know we were looking for the discriminant, which is actually this part, the part that we see inside the square root. So, in fact, we don't even need to use the quadratic formula. All we can write is we can say implies we saw this condition discriminant greater than or equal to 0. So we can just write 16x squared minus 4 times 1 times 4x x plus 6 is greater than or equal to 0. And we already see we have an inequality in x. Let's just expand this so we know this is 2 to the power 4 times x squared. I like to keep everything factored quickly because that helps maintain like if there's a factor, it makes it easier to factorize quickly because we know the factors, prime factors. So we get 2 to the power 8 x squared minus 2 to the power 4 x squared minus, this is 3 into 2, so 3 times 2 to the power 5 x. And actually, for equal to 0, we can just divide throughout by 2 to the power 4. And we get 2 to the power 4 x squared minus x squared minus 3 times 2 x greater than or equal to 0. And then this is 16 minus this, we get 15x squared minus 6x is greater than or equal to 0. And this we just factor out, so we take the 3x out, we get 5x minus 2 is greater than or equal to 0. And you can just, of course we can just say 1 is greater than, 1 is less than, but just to reinforce the concept of looking at the sign diagram, I would like to do this with a sign diagram, which is quite easy. What we do, we just draw a number line here. I can let this be 0 here somewhere. And we look at the critical values that we have here. We have a critical value of 2 over 5 and 0. So let's let this be 2 over 5 and 0. Alright, let me zoom in a bit so we can do this a bit quickly. 2 over 5 and 0. And now all we have to do is we just substitute a value in between to see if this is positive. So if we let, for example, let it be 1 over 5, x be 1 over 5. So if we substitute 1 over 5, we know this is 1 minus 2 times 3 times 1 over 5, and we know this is already negative, so the entire thing, the product will be negative, and that is already negative. So we can just write here this is negative, and this is, then we know this is positive. This is positive. You can substitute as well. There's no, and that's there's no squares here, so we know this is positive. And so I'll just draw this in just to make sure. We don't really need to do this, but the function is something like this. Of course, I've not looked at anything. Well, it should be something like this, but I haven't looked at any asymptotes or anything. But this is just how we can use a sign diagram here. And what was the initial condition? It was for it to be greater than 0. So all we have to do is for x to be greater than or equal to 0. No, for it to be, it was 3x times 5 x minus 2 to be greater than or equal to 0. All we have to do is we just look at the sign diagram here, and we see that of course it's greater from this point to here and from this point to here. And so we just say x greater than or equal to 2 over 5 and x less than or equal to 0. And so if I go back here, if we saw this inequality implies x less than or equal to 0, x greater than or equal to 2 or 5. And if we look at what, this is exactly what they were asking us to prove. Looking here, x is less than or equal to 0 and x is greater than or equal to 2 or 5. And so we have already done the first part. And you can see how we use this idea of just using the equation and finding out what we're trying to solve for. And now let's go back to our goals. Of course, we found it for x. Now we use it to find a restriction on y. And how can we do this? Well, everything's given. We do the same thing, just with y. So as for x squared, I'll just make it bigger so we can write nicely. 4x squared plus 16x plus y squared plus 24x equal to 0. I'll just do this a bit quickly, because now we know we can just let x, we're trying to make this a quadratic in x. Plus y squared is equal to 0. And now again, as x belongs to real, implies discriminant greater than or equal to 0. And here we know that we can find the discriminant again, which is 16y plus 24 squared minus 4 times 1 is greater than or equal to 0. So 2 to the power 8 y squared times, we can just do this a bit faster here. So I'll go up something on here. So we're almost finished. All we need to do is we just go 2 to the power 3 comes out here, and we get 2y plus 3. And we get all the square minus 16 is greater than or equal to 0. Therefore, all we have to do is we just say 2 to the power 6 times 4y squared plus 12y plus 9 is minus 16 is greater than or equal to 6. Sorry. And we just have this where we say, I can just divide this throughout, and then we solve the quadratic, of course. So 4y squared, I can just, we know this is 2 to the power 4 16, so I'll just leave the 4 here, so I got 16y squared plus 48y plus 36 minus 1 equals 0. 16y squared. We're just solving this basic quadratic now. That's all that's left in this problem. So we can just use 20 and 28. So we get 16y squared. 20y plus 28y plus 35 is greater than or equal to 0. 4, we can just take the 4y out. 4y plus 5 plus we can take the 7 out, and we get 4y plus 5. And therefore we have 4y plus 7 times 4y plus 5 greater than or equal to 0. And again, we can draw a sine diagram. As I said, I would like to use this because this is something that is very useful in the IB course. So we know our critical values are minus 5 over 4 and minus 7 over 4. So I would just write those here, minus 5 over 4 and minus 7 over 4. If we quickly look at our signs here, all we can see is if we substitute minus 6 over 4, what do we get? This will be negative, and this will be positive, so it will be negative, which is something in the middle, 6 over 4. So we know this is negative, something out here is positive, something out here is positive. So our function is looking something like this. It implies we only need, because it's greater than 0, we only need to use this part, so we know y is greater than or equal to minus 5 over 4, or y less than or equal to 7 over 4. we can just write it nicely here. Implies y greater than or equal to minus 5 over 4, or y less than or equal to minus 7 over 4. And that was it. So this is actually a very small question. I took quite long looking into it, but I just wanted to bring out the strategy and the general uh, approach which we could use here. And of course you don't need to the sine diagram. If you see the quadratic directly, you can just solve it. And I just went through a more elaborated approach, but I feel it is important to see that the beauty of different approaches and how finding one trick or one certain strategy can really help us solve a problem. So thank you for watching. I hope you enjoyed the video. Please, if you enjoyed the video, don't forget to like, share, and subscribe. And I hope to see you next time.